Total internal reflection is one of the most fascinating concepts in physics, and this is really how it works. First, I'll have to give you some conditions that must be satisfied before total internal reflection occurs. The number one condition for total internal reflection to occur is that light must be traveling from a denser medium to a less dense medium. That's the number one condition. And the number two condition is that the angle of incidence in the denser medium must exceed the critical angle. That is basically the two conditions that must be satisfied before we have total internal reflection. Don't worry, I'm going to explain what these things mean to you. So let's say I have a denser medium. Let's say, for example, let's say I have a glass here. So this my glass is the denser medium. So for total internal reflection to occur, I must have light traveling from this place. So light must be traveling from here. Let's say, let me make this the normal, and then this region here is the air. So let me name this. This is glass, and this is air. Now, light must be traveling from a denser medium to a less dense medium. From what we know that refraction is the bending of light. Bending of light means that if light is probably going through a certain path, let's say the light is coming from here and it gets to this place. There are two things that can happen here, but one of those things is not that the light will continue to move in this path. The light can no longer continue to move in this same path, I mean, to complete a straight line. But what will happen is that the light can either bend towards this horizontal line here, which is away from this red line, or the line will bend closer to this red line. Now, when light travels from denser medium to less dense medium, what happens is that it will bend away from the normal. The normal is this red line. So meaning that light is going to bend in this manner. So let's see. Yeah, something of this nature. So you can see that this is no longer following the path that it was following before. Now it has bent away from the normal. If it was the reverse case, that is from a less dense to a denser medium, it would have tilted towards the normal. So let's proceed with this. As light was incident from this place, the first condition I gave was that light must be traveling from a denser medium to a less dense medium. Now, here's what now happens. If I continue to tilt this line, let's say this line now, I decide to tilt it because refraction will always take place. The implication is that this refracted ray will also tilt up more. So the more I tilt this to the left, then the more this one will tilt up as well. So let's say at a particular point in time, I had tilted this line, this incident ray, up to this point. Then what will happen is that this particular ray of light would have been so much that it will now be on this line. And what you would notice at this point is that at that time, the angle of refraction would have become 90 degrees. The angle of refraction would have become what? 90 degrees. So this is a 90 degrees angle. So this is the new angle of refraction. So what happened at this point is that whenever this has happened, then the angle of incidence has a certain value. That value is what we know as the critical angle. So the critical angle is the angle of incidence in the denser medium when the angle of refraction in the less dense medium is equal to 90 degrees. So if you remember the condition I stated at first, I said number one, light must be traveling from a denser medium to a less dense medium. And number two is that the angle of incidence in the denser medium must exceed the critical angle. So what does that tell us? If this was the angle that this incident ray got to before the refracted ray aligns directly with this horizontal line. So what do you think will happen if I decide to just tilt this thing a little bit further? So let me tilt that a little bit further. Any little tilting further, you can tell that this ray of light will no longer appear as though it was refracted. It will definitely bend inside. And it's at this point that you say that total internal reflection has occurred. And that is what the concept of total internal reflection is. So, if you want to see more videos like this, you can follow. I'll see you in the next one.